welcome to our trend report briefings of 2023. Today, we will cover the trends from the climate book. I am Christina, and I am joined by my colleagues, Ryan and Mark. So Ryan Hogan is a consultant here at FTI as well, as I am as well, as is also Mark. Ryan and I co-authored the climate book, and we will walk you through this session today together. So to get started, let me share my screen. Hold on one second. Can you see my screen?
Yes, Christina.
Okay, perfect. So before we dive in, we want to briefly introduce ourselves. So I'm Christina. My background is in law, but then I moved into the visual creative field where I ended up working as a creative director. And then about 8 years ago, I moved into the tech space where I then moved into management consulting with a focus on digital innovation before joining FTI. Ryan?
Yes, thanks, Christina. I'm Ryan Hogan. I do have background in strategic foresight, receiving a degree in strategic foresight from California College of the Arts. My experience includes developing scenarios for different multinational corporations. And within FTI, some of my focus areas include space, telecommunications, and the environment.
So what will we cover today? So I first want to kick us off with a little bit of an introduction to FTI. Then talk about this year's trend report in general before diving into the specific energy trend highlights. Then we'll go to a few key takeaways before then closing out on a Q&A. Some housekeeping and just general announcement. So please ask any questions or comments, put those in the chat. As I said, my colleague Mark will interact with you and collect these questions so that we can address them at the end of our session. We are recording this session, as you've heard earlier, and we will make that available on our website. So if you want to rewatch it, or if you have friends or colleagues who you think this would be interesting for, you can access it there. And then just last but not least, just a reminder that you can download our trend report on our website. It's free to download. So FTI, Ryan and I have already told you a little bit about what we do, but let me just give you a brief introduction about what we're doing at the Future Today Institute. So the Future Today Institute is a strategic foresight institute that was founded by Amy Webb back in 2006 already. We help organizations navigating uncertainties and provide them with tools to work towards the future that they prefer. And we do that by using our methodology, which is based on data that we have available now, and as well as specific evidence. So we use that then to lay out different versions of plausible futures. How does that look like? Let me show you. So this funnel here represents our methodology. On the very top, you see the orange area. So that is our base layer. That's our first step. And there we look at what we can know, meaning we're looking at signals. What are signals? So we define signals as information that indicates change. We then look around, and if you find signal clusters, then we start to formulate trends based on those clusters. This is our very, very foundational work, and everything else is layered on top of that. So, and this is also the area where our trend report is positioned. So we really want to make this foundation available to as many people as possible. That's why we release this trend report every year. The next step in our methodology is the purple layer. So in the purple layer, uncertainties, we look at what we cannot know. So uncertainties we define as developments that no one entity can control. And then based on those insights, together with what we can know, we start to formulate perspectives of what possible futures might look like and write scenarios based on those perspectives. Last but not least, then for our clients, we work with them then to identify specific opportunities and threats that are a result of the scenarios that we laid out, and then determine how they can achieve the future or the element of the futures that they prefer. So let me move on to our trend report overview. Let's start off with a couple of numbers. So our 2023 trend report is our 16th anniversary edition. Yes, we've been doing this for 16 years. We identified 666 trends. I know that's a weird number, but that's we counted several times. That's what it turned out to be this year. And we are talking about them or writing about them on 819 pages. If you're projecting 1.2 million downloads this year, the numbers like go a little bit up each year. Last year we had about 1 million, so that is what we're looking at for this year. We have organized the content for you in 14 different books. We are covering such topics as AI, metaverse, mobility, or supply chain, among others. And just one thing I want to point out here is that we have an executive summary book this year, which gives you the key takeaways of all the different books. So that might be a good starting point to just get an overview over all that we offer in regards to information. So each year, we choose a theme for our trend report, and this year we chose focus. Why did we choose focus? Because, as you know, there have been so many exponential developments in completely different areas last year. So we had exciting progress in nuclear fusion, which Ryan will touch on later on. Of course, we have ChatGPT, and then we have, of course, the developments in Ukraine, as well as a fear of a global recession. So with all of these things going on, it's easy to miss which developments are actually the most important for you or your organization. And you can get sidetracked and just overwhelmed. So by choosing this word, we wanted to express our desire for you to not do that, but really hopefully use a trend report as an additional guideline for you to determine what is really important for you. Without further ado, let's dive in. Let's dive into the energy trend highlights. So what we did is we curated a list of 15 microtrends from the different subsections of the book. So we selected the trends that we're presenting today based on 2 criteria. First, of course, importance, but then we also included some trends we found particularly interesting, but might be a little bit more niche, just to give you a good cross-section of information on what is happening in the field. Some highlights in general. So there were a lot of highlights last year. Major milestone in the EU energy. Wind and solar produced more electricity than gas in 2022. In California, California was able to use exclusively renewables to cover their energy needs for a few hours on May 8th. Very exciting. Then investments in clean energy crossed for the first time the $1 trillion threshold, and also matched the investment in fossil fuels for the first time. And then, of course, major legislation happened, the Inflation Reduction Act in the US, and then further alignment on the Fit for 55 package in the EU. Okay. So for those of you who have read the book, which I don't know how many there are, we're starting off here with solar. So I'm going to do that here as well. And I want to talk about perovskite cells. What are perovskite cells? So traditional solar cells use silicon for the layer that absorbs the sunlight. And perovskite cells use, you guessed it, a material called perovskite. Why is this important? So using perovskite has a few really great advantages to silicon-based cells. First of all, they're cheaper and easier to manufacture. And then they're transparent, flexible, and much lighter than silicon solar cells. I know it's kind of difficult to wrap your mind around, like flexible, transparent solar cells, but that's what they are or can be. What happened here last year? So first off, researchers managed to break the 30% energy efficiency barrier for the first time. And so that makes them slightly more efficient than silicon solar cells. So what is energy efficiency. So with energy efficiency, we mean the proportion of sunlight's energy that can be converted into electricity. So then also the second thing that happened last year is that perovskite cells were made more durable. So that's one of the vulnerability spots of this technology. So traditional like silicon solar cells can last like about 25 years and keep the most like they don't deteriorate. However, perovskite cells like last much shorter, like a few months to a year, which of course is a huge problem. However, they managed to expand the lifespan last year to 5 years. So still a long way to go, but that's still exciting progress. What does this mean for the future? So of course, if you have increased energy efficiency and a decrease in cost, that helps solar to gain a bigger footprint. But I think the most exciting thing about perovskite cells is just that there's an expanded area of application. So for example, you could put them on parts of buildings that you cannot put solar cells on, for example, windows, because they're transparent, or, you know, facades that are uneven. Stuff like that. You could also use them indoors. They work well on low light conditions to power smaller electronic devices, or they're even flexible enough to be on portable or wearable electronics, such as like a backpack or even clothing. So when you think about that, then I think those are very, very exciting perspectives that open up here in the future. Next up is solar adjacent technology, so using the coldness of outer space. So what do we mean by that? So the reason why it's adjacent is because that technology produces energy at night, versus like solar obviously produces energy during the day. So what do we mean by using the coldness of outer space? So what we are referring to here is a process called radiative cooling. So an object cools down at night and radiates its heat out to outer space by emitting infrared radiation. So this difference in temperature can be used to generate electricity. And why is this important? So this technology, a thermoelectric generator is called, could complement solar panels and would increase power generation capabilities from daylight only to nighttime and bring some consistency here. What happened last year? So overall, thermoelectric generators are not new. However, last year, researchers were able to produce 50 milliwatts of energy with this process, which is tiny compared to what solar panels produce. Solar panels produce about 200 watts. So just to give you an idea, 50 milliwatts is enough to power an LED light bulb at about 10% of its brightness level. So not super significant, but it could really, you know, complement other initiatives. So for example, in the future, first of all, hopefully more energy would be able to be harvested. And in that case, it could help provide energy, for example, for street lights or, you know, just other energy needs at night that it might not just be as significant as what we need during the day. And it also would widen energy access. So these generators don't need batteries. So they could be used to charge, for example, devices off the grid, which is another thing that I find very compelling. Moving on to new wind, starting off here with offshore floating wind turbines. What are offshore floating wind turbines? So there's two types of offshore wind turbines. First, there's the one we all know, the fixed bottom, most common type, and used in shallow water. So those are the ones you see when you're looking out into the ocean and you see those turbines. So floating turbines are not directly anchored to the ocean floor, but they are floating devices that are connected to the seabed via anchors, and they're used in deep water areas. Why is this important? So winds are much more stronger and much more consistent in deeper offshore areas. There's also reduced visual impact. Again, I don't know how you feel about it, but in general, I would prefer like a cleaner view out into the ocean. And then, of course, it's opening up new geographical areas for wind installations. What happened in this area last year? So the Biden administration wants to reach 50 gigawatt of floating offshore wind by 2035. And the first ever, now this is a mouthful, wind lease sale was initiated to support floating wind developments. And that happened in Central and Northern California. Scotland is building the world's biggest floating offshore wind farm. And then overall floating offshore projects doubled in 2022. And actually the UK has the most gigawatt of offshore wind projects in development. What does this mean for the future? So wind speeds in the ocean are much stronger. I already mentioned that, but they're also usually highest when electricity demand is high. So during the afternoon or evening. That's different from wind from land. On land, the wind is usually strongest at night. So this would help stabilize the energy supply. Another aspect is that many large cities are located near coastlines. So offshore floating wind increases the access to clean energy for these urban areas. So another wind technology that I find really interesting is going bladeless wind turbines. So again, what are they? Bladeless wind turbines are relatively new technology, and they consist of a tower with magnets at the top. And then the wind passes through it and a vortex is created, and that drives an electric generator. Why is this important? So you can probably guess from the picture we have here, it's much less disruptive. It's quieter, but also it doesn't disrupt wildlife. It's much less expensive because there are fewer moving parts. And they're also able to reach higher energy levels compared to, energy efficiency levels compared to traditional wind turbines. So 60% versus 40 to 45% of traditional wind turbines. What happened here last year? What was the what has been developed, or what was the progress? That was the word I'm looking for. So the focus on the development here has been driven by a couple of startups, and focus has been on making it usable on residential rooftops, as well as produce energy with these in a wide range of weather conditions. How is this important for our future? So this technology could help making businesses and consumers energy independent. And it could also make wind capable to be used in urban areas or nature protected areas, because it's just so much less invasive than traditional wind turbines. This closes out our wind section. And now I want to quickly touch on other renewable energy sources. So here we are talking, want to mention supercritical geothermal. What is supercritical geothermal? So supercritical geothermal refers to drilling deeply into the earth to reach temperatures hotter than 370 degrees Celsius and pressures that exceed 218 atmospheres. It's a lot of pressure, even if you don't know what atmospheres is. So the water that exists in such depth is in supercritical state, meaning it is neither liquid nor vapor, but has properties of both. So in that state, water can store and transfer 4 to 10 times more energy than in liquid or steam form. So why is this important? So if we can utilize water in the supercritical state for energy generation, we could have access to an almost limitless energy supply, because you can access this kind of energy almost anywhere, different from traditional geothermal, where you need very specific geographical conditions. The energy density is extremely high, as I mentioned earlier, and of course, it's a clean and consistent energy source, so contributing to the grid stability. What happened here last year? So very exciting. A startup developed a new drilling method, which is not mechanical, but instead vaporizes rocks. And they could dig with that up to 20 kilometers deep. The first plant is supposed to be ready and ready to roll in 6 years. So that would be very exciting. And then in Oregon, there was a project where they deepened the access of a well to access 400 degrees Celsius water. So if the project is successful, then that could provide energy for 3 million homes, which of course is really significant. What does this mean for the future? So again, we could have access to consistent, plentiful, renewable energy. However, there are still significant technological barriers that we have to overcome. just to get that far down into the earth. The upfront costs of these things are extremely high. And then there's also the fear of inducing earthquakes with this method, as well as the impacts on groundwater need to be explored. So definitely still some major aspects that need to be explored here before this can become a reality. Moving on to fuels and kicking this off with hydrogen. And I want to spend a minute here on just the basics, because hydrogen can be a little bit overwhelming. So hydrogen is the most abundant chemical element on Earth. It's contained, for example, in water or in plants, many other things. However, it is very rare as gas. So the main challenge is, or a big challenge is, to harness hydrogen as gas on a large scale so that we can use it as fuel. How is hydrogen produced? There are many, many ways that hydrogen can be produced. Some of them are clean, most of them are not. So that is a little chart that you see here on the screen. Brown and gray hydrogen are produced burning fossil fuels, and blue hydrogen is also produced with fossil fuels, but using CCUS technologies to remove or reduce emissions. And then the green hydrogen is the one that is using renewable energy for production. Bad news is that 99% of hydrogen is produced using fossil fuels. So why is that? So producing it with renewable energy is just very expensive. The equipment is very expensive. There's very high energy needs, and if energy is expensive, so that raises the cost. And then there's also the limited infrastructure. Why is hydrogen important? So again, hydrogen can replace fossil fuels in a variety of applications, transportation fuels for heating and power generations in homes, or to balance the grid. It can actually store energy. There are more applications, but that are just a few. What happened here last year? So mainly two things. First of all, it got a lot of policy support. So 9 countries adopted hydrogen strategies. These 9 countries cover around 30% of global energy sector emissions. And now the total number of countries that have adopted hydrogen into their environmental strategies is up to 26. The second thing is that processes were developed to make the production of green hydrogen more efficient and less expensive. For example, trying to make the process work at lower temperatures. They actually managed to do that successfully, using steam instead of water, or also using light within the process or different materials, again, to lower costs and increase efficiency. What does this mean for the future? So obviously, a decreased cost of green hydrogen would make this a very viable alternative for fossil fuels use in transport or industrial processes. But it also could increase international trade of hydrogen, which then can support lower middle income countries that often have abundant renewable energy resources to produce hydrogen and then export it. So that would be a great benefit. Moving on to another fuel, a biofuel. So the same as with hydrogen, I just want to spend a moment on the basics, because this is also a little bit confusing. It's just a very large area. So what are biofuels, or what is biofuel? So biofuel is derived from biomass and domestic or industrial bio-waste. So an example of biomass could be crops such as corn or sugarcane. Domestic bio-waste is food scraps, for example, and industrial bio-waste could come from food processing, agriculture, or forestry. Examples of biofuels are ethanol, biodiesel, or biojet fuels. Why is biofuel important? So biofuels are also a renewable energy source that can be used instead of fossil fuels for transportation, heat and power generation, as well as chemical production as feedstock. What happened here last year? Similar to hydrogen, biofuels got a lot of policy attention. Europe, US, Canada, and India all have extended support. And then there were new base materials explored to be used for the production of biofuels. So one of those is hemp, which you see here on the picture. Hemp has found to produce more fuel per hectare than any other land-grown crop. And it also can be produced quicker because it doesn't have to be dried, like, for example, corn or sugar, the 2 ingredients that I mentioned earlier. So another base material is algae. So algae has a really fast growth rate, and it grows on non-arable land, so it doesn't compete with food crops, which is a big deal. However, algae is very expensive to use for biofuels because it's just very picky in regards to what it needs for growing conditions. For example, it needs a very specific nutrient concentrations. So in the UK, a team of researchers has used coffee grounds as feeding ground for microalgae, which has lowered the cost significantly. So very exciting process. If that can be scaled or if other ways can be found, that would be grow into a really good alternative to use as a base material. So what does this mean for the future? Similar to hydrogen, of course, if the cost of biofuels could be lower, then this could be a really great alternative to fossil fuels. So before I hand you over to Ryan, I want to mention innovation in the fossil fuel energy production space, specifically rededication of contaminated land. What is that? So lands that were used for landfills or for mining or other contaminations are being repurposed for renewable energy development. Why is this important, or why is that being done? So often these lands have existing infrastructure already that can be used for, it is helpful for energy production. Easier permitting is often the case. The land is often cheaper, and therefore it's just very attractive for renewable energy production. What happened here last year? So the US Environmental Protection Agency identified about 160,000 sites that are suitable to be repurposed. And the US Department of Energy has invested $8.4 million to assess geothermal potential of abandoned oil and gas wells, and 4 projects have been initiated here. What does it mean for the future? Again, of course, it happens to deepen the footprint of renewable energies, but I think another really interesting feature is that it could provide jobs in these often remote areas where there is not a lot of alternatives to find work. So with this, I am going to go quiet, and thank you so much, and I will hand you over to Ryan. Ryan, over to you.
Yes, thank you, Christina. And I did just want to take an opportunity to reiterate a bit of what we've already stated. We are merely scratching the surface as we go through some of these trends, and we really do invite you to go to the website, download the trend reports, dive in, see all the material, all the associated impacts with those trends, and join as many webinars as you can and have interest in. But as we do continue on, and as we look at the trend of new nuclear, our focus will be on fusion power. And of course, fusion power is a process that mimics the process that we can find in stars in our solar system, or even within our sun to produce energy. And this is done by jamming or fusing parts of atoms together, which often results in a heavier element. Now, the goal of fusion power is achieving what we call break-even energy generation. In other words, this is having a reaction produce more energy than the amount of laser energy that is used to drive the process initially. Now, of course, this would have an immeasurable impact, potentially giving us unlimited energy that is both environmentally friendly and safe. Now, I do have good news. This past year, scientists at the Lawrence Livermore National Laboratory were actually able to achieve break-even fusion for the first time. This is a very astonishing feat, and there are great implications for what that will mean for us moving forward. But we do still have much ground to cover before fusion becomes a feasible form of energy. And of course, it remains to be a polarizing topic within the subject. So that could also add more hurdles to its potential adoption. If you could advance to the next slide. To highlight a couple of new forms of energy production, first we'll look at energy from thin air. Researchers from the National University of Singapore have actually developed a moisture-driven electricity generation process. Basically, they've created a device that can harness moisture from the air to generate electricity. And they do this merely using thin fabric, sea salt, carbon ink, and water-absorbing gels as the key materials. So this is a sophisticated process, yet it uses very simple materials in its execution. This form of energy generation is meaningful because one day such technology could be used to power wearables, and these include health monitors, skin sensors, and also information storage devices. In a similar vein, we're seeing a lot of traction when it comes to harnessing kinetic motion for energy generation. Companies such as PaveGen have installed special pavement that can absorb the footsteps of pedestrians and convert that energy to usable power. We also know of an instance of a town in Italy that used cyclists on stationary bikes to power their local Christmas tree when Russia had cut off its natural gas supply. So the latter highlights how these measures could serve as alternative energy sources even in times of crisis. Or we can see recreational activities such as dancing now have dual purposes, not being just a form of entertainment, but also a means of energy generation. If you could advance to the next slide, please. In the area of minerals and rare earths, fortunately, we're finding new alternatives to these materials. Tetratonite is an alloy that can be used to craft high-performance magnets, and these magnets can be used in a range of devices, including electric vehicles, space shuttle turbines, and even wind turbines. The only problem is that this material is primarily found in meteorites. It's not really naturally occurring here on Earth. However, there is good news. Scientists have found a way to manufacture this alloy on Earth. And this could result in reduced need for rare earth elements, which would thereby reduce our mining of such elements, and in turn would reduce the devastation that this process causes. So not only can this material be used for energy saving and energy producing devices, it can also reduce our dependency on the mining of these rare earth elements. So it can really have some positive impacts in a few different ways and a few different outcomes. If you could advance to the next slide, please. As we segue to energy storage, we're really seeing some breakthroughs with iron batteries. Iron is one of the most widely available elements on the planet, so naturally, it's very advantageous to use this abundant resource for clean energy storage. And these batteries are simply made from iron soaked in salt water. They do cost far less than traditional lithium-ion batteries, and they're much more durable and safe alternatives. The company Form Energy's iron air battery technology uses oxygen in its process, and it can store energy for up to 100 hours. Such extended storage capabilities are excellent for both solar and wind applications. Another company, ESS, is using its iron flow batteries and solar arrays in parts of California that are often at high risk for forest fires. So one of the big positive applications of these batteries is that they can ensure that services can still operate even in times when transmission lines are blocked or cut down. And if we could advance to the next slide, please. Now we'll be focusing on a couple of trends related to energy transport. And when it comes to energy transport, there are some significant advances happening on Earth, but also there are some significant advances happening beyond our home planet. Three organizations, IMROD, Airbus, and the European Space Agency, have recently conducted a demonstration to showcase the potential of using space-based solar power. Now, this could be a very amazing thing if we are able to achieve it at scale. As we know, just one satellite equipped with solar panels could provide enough power to more than 1 million homes here on Earth. More importantly, this form of solar power could help us achieve some of our ambitious net zero emissions targets, and it could help us actually achieve them by the year 2050. So one really positive thing about this, if we can look into the future, this technology could enable a future where solar panels capture unlimited solar energy and perpetually transmit that solar energy down to Earth. If you could advance to the next slide, please. But if we do shift our focus, and if we do keep our focus here on our home planet, ultra-high voltage power lines could also serve as a solution for more effectively using renewables such as solar and wind. Ultra-high voltage power lines will be able to transport 450 gigawatts of solar and wind power from the Gobi Desert. It also can take hydroelectric power from some of the southwest region of China, and it can then transport that energy to other regions of China and even into more urban areas. These cables can span such long distances that power could be generated from a location at the height of its day, and that same energy could be provided to another location in a time zone where it is already dark. More domestically, the company Breakthrough Energy has called for the US to triple its high voltage transmission capacity, which would use rural environments to power big cities within the United States. And such energy transport would maximize the use of renewables, including solar, wind, and hydroelectric, as we already addressed. And if you could advance to the next slide, please. And finally, as we conclude looking at specific examples of our trends, we will focus on the grid. We are very interested in microgrids. We're very interested in what that could imply for our future, what that could do for instances of storms or natural disasters. But as we look at microgrids, these are local electrical grids which are defined boundaries, and they stand alone or they are isolated. They're pretty modular and can impact certain areas, and they're not impacted by adjacent grids and the power that can flow through those. By isolating these microgrids, power can keep flowing when other sections are taken offline in the event, as I said, of storm damage, wildfires, and even cyber attacks. Microgrids are important because they will prevent outages caused by future extreme weather events. And we know this because even during the 2021 winter storm in Texas, more than 160 buildings on the campus of the University of Texas at Austin never lost power because they were connected to one of the nation's largest microgrids. If you could advance to the next slide, please. As we do conclude our exploration of energy-related trends, we do want to remind you that we've, again, merely scratched the surface of these trends. We invite you to download the trend report so that you can take that deep dive into our comprehensive list of energy-related trends. Within that edition, you will also find climate related and climate tech related trends. And Christina and I will be back this coming Monday, to explore those. So we do encourage you to sign up for that webinar. Again, I would very much encourage you to sign up for webinars from my colleagues, especially for areas that interest you and are pertinent to your organizations. We do take a lot of pride in the work that we put into this, and we would love for you to be able to take that information and apply it, and really inform your thinking around the future to create future-focused strategies that are equipped to withstand a lot of different unknown variables. But with our reports, we try to go beyond just including trends. That's just the first part of the work. We often include scenarios, and scenarios help us plan for the future and rehearse the future. We also include strategic questions for your companies to consider. One other thing that we often do is include opportunities and threats. And before we fully conclude, I will leave you with a few of the latter, a few of the opportunities and threats, just to challenge you to better consider how these trends can impact maybe your organizations or even your individual daily lives. So first, there is obviously an apparent energy opportunity. There has been a perceived shift in the power dynamics within the energy sector as customers search and demand for more environmentally friendly products and services. And as the grid does become more decentralized, I just want to ask you, how can your company rethink energy, whether that be a possible additional product or an alternative form of energy production? But shifting that frame a bit, as the energy sector does become more disrupted by new players and new entrants, and as we have seen an increase in the past year in tech workers leaving their respective industry to take jobs in energy and climate, there is still a perceived threat of a shortage of qualified workers in the future. So in the future, as roles become more specialized, proper training and education for this workforce will become difficult, especially as universities can be slow to adapt. So as energy becomes a greater value proposition, energy-focused organizations will have to source and train much of the available talent on their own. So while there is an overall opportunity in the energy sector, it might remain difficult and there might be hurdles because of a lack of available talent. If we could go to the next slide, please. With that, we have concluded our webinar covering energy-related trends from our 2023 annual trend report, and we will now open up the floor to questions.
Thank you, Ryan and Christina. That was a great synopsis of the trend report. I'm going to go through some of the questions that have come in through the Q&A. There was one that was a little bit of a housekeeping one. So yes, we are recording this webinar, and yes, we will be posting it to our website. So if you want to reference back to it, you can. So with that, I'm going to go to Christina there's a couple questions that came in that talked about offshore floating wind turbines and the concern around if there's any safety concerns, what might be some of the effects on sea life with these offshore wind turbines, and just wondered if you might be able to speak on that. You are on mute, Christina.
Classic, after 3 years of remote, still happening. So the short answer is yes, there is going to be an effect, but nobody is really sure yet how, because it can disrupt, movement of wildlife. It can disrupt the movement of other things. We just don't know. It can affect the seabed. So those are definitely things that need to be closely watched as this technology is being rolled out. However, I also want to mention something that we're going to talk about on Monday is floating cities. So, and in these concepts, the squares that those floating cities are built on are being utilized to actually build a sea life underneath those floating squares. So I don't know if it could be an option, for example, to take a similar approach with those floating offshore turbines, so that it would actually help the ecosystem and not disrupt it. But that is something that remains to be seen.
Thank you. The next question was referring to nanocarbons. And
Mm-hmm.
Christina, I know that you and I have talked about nanocarbons and for the perovskite cells, but I don't believe that we found any more information on them. I do know that the question was whether or not they would be good for paints and for building facades. And I know that a lot of buildings are considering algae as a source of renewable energy and integrating it into the building facades. And they are showing that that is much more efficient with absorbing sunlight and generating energy. But Christina, I don't know if there's anything else you want to add on the nanocarbons at all.
The only thing I want to add is that I know that nanocarbon is contemplated as a material to use in conjunction with perovskite cells, but I don't have any further information on that at this point. And I just want to quickly say that Mark actually authored our supply chain book. So some of the topics here he also discusses in his book. So he is going to join us here on our Q&A and provide you the best answers possible.
Yes, thank you, Christina. And actually, the next question is kind of in tangent with that. And it was about whether or not commercial air travel will ever be fueled by something cleaner than hydrocarbons.
Yeah.
Actually, one of the signals that I captured when I was looking at supply chain and logistics was, I believe it's Alaska Airlines and the company 12 have developed something that they're calling E-Jet, that they're calling carbon neutral jet fuel, which is made from electrified CO2 and water. So yes, that is definitely in play. But Christina, are there any other signals or trends that you saw with regards to this?
Yeah, so we had also actually an internal discussion just last week about EV tolls, so which are basically like they're reminiscent of like and now of course I can only think of the German name Hubschrauber of the of electric how do you call them?
Helicopters?
Yes, helicopters. Thank you so much. Just electric helicopters. So which can fly several hundred miles, and it could also be an alternative to hydrogen in certain instances.
Great. Ryan, this next question is coming to you. And the question is about the transportation of energy from space from solar panels down to Earth. Could you maybe clarify that a little bit?
Yes, so this would actually require it to be wirelessly beamed back to Earth. And this needs to be in a safe and controlled way, either as microwaves or laser beams. So that's the short answer for that.
Great. And then maybe you could keep just further explanation, or if there are any health implications regarding the high voltage energy lines.
Yeah, I'm sure there has been some research on that. And I can't speak to all different health concerns, but I know the National Cancer Institute has looked into this, and so far they have not found evidence that this form of energy transport would cause cancer. So that is a more specific, I know, health concern, and I know there are obviously other impacts that could have, but I do think that is promising that we already have evidence in that regard for it not to be that increasingly adverse.
Thank you. We're going to take one more question. And again, just a quick note that we are recording this. This will be posted onto our website. If you do want to join, Christina will be hosting another webinar on Monday, I believe, continuing this conversation. So please go to our website and feel free to sign up for that if you want to continue the conversation. The last question I'll let Ryan or Christina answer. It is, which technologies do you think we will see the most adoption in the near future from a practical standpoint, including cost?
Ryan, do you want to go, or should I interpret your silence? Were you contemplating?
I'm contemplating, yes. Sorry, yeah. So just thinking through that a bit. If you have a response.
Okay, so sorry. Okay, so I mean, honestly, I think solar and wind just are getting the most support. So those obvious technologies that I think we'll explore the most over the next couple of years for sure. It's no surprise there from my perspective. But Ryan, curious what you cook up.
No, I think those. Yes, I would agree with you. And I think the important takeaway is, of course, to scale these technologies, we'll have to look at other points along the way. It's not just the collection of energy, it's how we transport it and how we store it. And as we've looked at some of these things today, I think it does highlight, just what all is required along the way to scale these applications and technologies. It may not be that difficult to actually harvest the energy, but it will also be important for how we're able to use it and how we're able to get it to the places that we need. And as we come up with solutions for that, these renewables that you mentioned will hopefully scale.
Yes, Ryan, such a great point. Exactly, the infrastructure needs to be there to be able to integrate renewables into the grid on a large scale. So, and infrastructure developments are much slower than we wanted them to be. So that was such a great point. So I am going to stop sharing my screen. I'm going to close us out now. Thank you so much for joining us. Again, quick reminder, we have Ryan and I are going to host the next session on Monday, talking about climate technologies. You can find the recording of this session here in a couple of days, and you can download our trend report on our website. Thank you so much for joining us, and have a great rest of the day.